Students, we will look at the problem number 2 in the graphical method. When we worked out, we considered both are less than or equal to type in the previous problem. Now we will also work out similar question, but there is negative. This is another possibility. So we will check how do you do it. So straight away inequality as equality. So first step will be minus 2x plus y is equal to 1. Take x equals 0, y equals, if x is 0, y equals 1. If y is equal to 0, x equals, put 0 here student, minus 2x equals 1, x equals 1 by minus 2 or minus 0.5. 1 by 2 is 0.5 minus 0.5. First point A will be 0, 1. In a hurry, don't take like this 0, 1, whereas point B minus 0.50, x, y, x, y. Let us look at the next one. Next one is x plus y equals 3. If you take x plus y equals 3, first step what you should do, x 0, y 3, 0, y equals 3, y is 0, x is equal to 3. Therefore, point C is x, y 0, 3, whereas point D is 3, 0. So, we have A, B, C, D. With the help of this, can we solve? But before solving, you need to consider, are there any negative? Yes. Where it is negative? X negative. So, in x axis, there is negative also you have to take. These are all positive, negative. So, if I take 1 centimeter as 1, 2, 3, I have to take minus 1 also. In between minus 0.5 will come. Whereas y value highest is 3, only positive 1, 2, 3. Write the scale, 1 centimeter is equal to 1 unit in the x axis, same for y axis. Let us plot the point. We have come to this. Now draw the lines with corner points. First one is A, 0, 1, 0 x value, x 0, not to be worried, y value positive 1, y positive 1. This is point A. Point B is minus 0.50, x value minus point. In x axis, minus 0.5 means somewhere in between this. I will take this as point B, minus 0.5. So, we will draw this, take scale and draw it. So, this is line 1. Shall we take line 2 now? This is just to, this problem is to tell you, when you draw a line, corner points may come in negative x or negative y. Keep that also in mind. Now we will go for point C, that is 0, 3, 0, 3, this is C, D, x value 3, y value 0, that is just C, D is 3, 0. Join it, we will call line 2. You draw the lines with the help of the scale and the graph. So, I think you are good in lining, that you can draw it. So, here I have drawn the line just like that. Slight differences may happen, but in graph sheet it will be proper. So, A, B, C, D we have done. Shall we share the feasible region? Line 1, this is line 1, this is origin, less than means towards origin. Where 0 is there, 0 is here. Therefore, this line I have to take shading towards 0. If I take towards 0, I have this area, this area, this area, all this area less than 0 or towards origin. This also will come. Now, because of this condition xy greater than or equal to 0, from this line I have to shade, but not in other quadrants, only in first quadrant. This is in third, this is in fourth, second cut. That means I have to take only these two areas which are less than means towards 0 and comes in first quadrant. Students will look into second line now. This, is it less than or greater than? This is x plus y equals 0. This we will call 1, this we will call 2. This is 1, this is 2. This line, is it less than or greater than? This also less than towards origin. From this line, I have to take towards origin. Origin is here. Towards origin means from this, carefully observe, from this line, I can take this, I can take this, not other. This this all are less than. Due to non-negativity constraint, I cannot take second quadrant, I cannot take third quadrant, I cannot take fourth quadrant. I have to take only this and this. I will mark this as x, this as also x. This is from this line towards origin, here also towards origin. Tell me students, first step it was towards origin, means right mark I made these two. Whereas second one, when I take here from this line towards origin, means this and this. So both the area, what is common? That common region you call feasible region. Therefore, this is the area only in one of the inequality. This is also in one, not in both. Both the feasible region, both inequality, if you analyze, this area what you get is feasible region. Now, when we call that feasible region, whether we know all the corner points, we know A, we know O, we know D, but we don't know this point, we call it as E. How do you find? To find E, solve 1 and 2. So you have 1, you have 2, if you solve it, how do you solve it? Minus 2x plus y is equal to 1, x plus y is equal to 3. Shall we subtract so that y will get cancelled? Plus is minus, minus, here also minus. Minus 2x minus x minus 3x, y cancel, minus 3 plus 1. When you take minus 3 plus 1, it is minus 2. Minus 3 plus 1 will be minus 2. Therefore, x equal to 2 divided by 3, minus 2 by minus 3, 0.66, or you can take 0.7. Similarly, if I substitute x in, shall we take in the second one, easier, in the second one, which is x plus y is equal to 3, 0.66, if I take 0.7 almost, y is equal to 2.3. Therefore, exactly are not written, it is 0.66 approximated, so that you can identify here, 0.7 and 2.3. With the help of these two, if you take, sir, what if I take 0.666 only? No problem, this will be 2.333 only. Exactly you get 2.333, 0.6. We will take exact here instead of approximation, 0.666, 2.333. Now our next work, we have completed 1, 2, 3, any corner point worked out? Yes. Substitute the corner points. I have seen many answer sheets where students will take C, they will take all the points you take. Don't take all the points. A, O, D, E, corner points only you have to take, not the other points which is unnecessarily we have written here. Written correct because to draw. But for feasible region, only the corner points you have to take. Therefore, we have to substitute E, A, O, D for Z max. Shall we substitute one by one? First one, what is the point A? Point, what are the points? A, O, D, E. Point A is about, A is here, which is 1, 0, 0, 1. What is the point A? A is 0, 1. Substituting A as 0, 1 in this, Z equals 0 plus 1, 1. Next O is 0, 0. Z will be 0 plus 0, substituting x value 0, y value 0, which is 0. What about point D? Point D is about x 3, y 0, z is equal to 3 plus 0, 3. What about point D? 0.666 and 2.333, substituting z is equal to 0.666 plus 2.333, which is also equal to 3. Students, whether we want maximum or minimum, maximum is here also we get. We also get in this. This is line 2, which I just rub it out. So, this is all about graph. Here also maximum 3, here also maximum 3. We can conclude maximum is available. But there are two maximum. Now which one you have to take? No problem, take both as the solution. If all are 3 are maximum, 3 can be the solution. It need not be one solution for a problem. It can be 2 solution, 3 solution. Optimum solution can be any number. So conclusion, optimum value, students, this is how we have to write in exam. Optimum value is this highest answer 3. Yet there are 2 points at D or at E. Therefore D is x3 y0, or if you say x 0.6666 y 2.333, both are correct answer. But practically number of units when you take, either it is you can take 1 and this you have to approximate it to one integer. Mathematically you can take this. Shall we look at next problem? Students, now we will go for next problem. But what I will do in this problem, I will take the problem 2 as the base and all the varieties of problems will work out. You have to tell me what is the feasible region and how do you get the answer. I will consider this as less than, whereas this as greater than. So line 1 less than, line 2 greater than. Line 1 less than means I have to take this region towards origin, whereas line 2 less than or greater than, greater than. Line 1 less than, this is line 1 and line 2 is greater than. When this is this side, this is on other side. Repeat, line 1 here, less than towards origin, then this and this area. Line 2 is, if it less than, then this is the common region. Line 2 is not less than, greater than, not towards origin, against, then this and this. So line 1, this if I take, line 2 opposite, so then it will be this and this. Common area in that case will be this area. Student, this area is what you will call it. Sir, till what extent I should write? Since it increases on both the sides, it is an unbounded solution. Starting points are there, but end points are not there. No boundary to it. If this is the case, then you have to write the solution as unbounded. Feasible region, you have to draw it, shade it, you have to write LPP has unbounded solution. So I think understood. Same question, observe here, what if it is minimum? If at all minimum, among the maximum, the values what you get, choose the minimum, that is the answer. Dear students, in the case of what you have no boundaries, how do you consider here? Is it unbounded solution again? No. If it is maximum, maximum will come at any infinity. It goes up to infinity. Maximum I cannot find out. As it moves on x and y axis, values are increasing, unbounded solution. But if it is minimum, always keep note. If it is minimum, minimum value always lies at initial points. If it is minimum, then you have to substitute, write in your notebook, minimum value lies at initial points. That unbounded solution gone, no, in that initial starting points you have to take initial points, that is D and E. So we have to substitute Z is equal to x plus y. What is the point D? What is the point E? Point D is 30. Point E is about 0.66 to 0.33. Substituting Z 3 plus 0, 3, 0.66 plus 2.333, it is still 3, we want minimum. Minimum lies here as well as here, both are minimum values. We can conclude, is a very strange solution, it is minimum value lies at initial point. There are 2 initial points, 2 answers we got. We want minimum, both are same, that is the minimum value. So there are only 2 solutions for your optimum you have to take, but that 2 solutions are the least solutions. If at all 3 and 5 you got, choose 3 and conclude. So this is about minimum value. Students, I will make a slight change in this. What I will do now, the same problem, what if it is both are greater than? No, I will do this as greater than, this as less than. You answer this. Now line 1 is greater than, line 2 is less than. So, line 1 greater than means what I should take? Origin is here, from this do not take towards origin, against origin. So, I will just rub this first, okay, so that you can make out 0.66 to 0.33, line 1, same, see this xy is there, this if greater than less than will change only your feasible region shading part, no other regions, rest all remain same. Therefore, what is my work is drawing lines also same, corner points also same. Based on this, you have to change the feasible region. Okay, line 1, is it less than or greater than? Greater than, 0 is here, less than means towards origin, greater than means against. So, I can take this, but I cannot take in second quadrant, I have to take this and this. So, this area no BACE and this open area we have to take. Now, student, this is about line 1. What about line 2? Line 2 we have not taken. We will take line 2. Line 2 is this is the line 2. Is it less than or greater than here? Less than means facing towards origin. So, I have to take from here this side. So, this area and this area, but I want common area, I should take this as feasible region. So, feasible region is ACE. So, let us substitute ACE in the given one. If I substitute, let us assume it is Z minimum or maximum. I will take maximum in this case, because previous one I have just taken anything, that is okay, either maximum or minimum based on the question you can take. I have taken maximum. Z max is equal to x plus y. So, what is the ACE 3 points? A is equal to 0, 1, where x is 0, y is 1, answer is 1. C, what is the point C we have? It is, C is 0, 3, x 0, y 3, 0 plus 3, 3. What about point E? 0.66 to 0.333, 0.666 plus 2.333, answer 3. Since here two answer coming, it is coming equal, but all the case it need not be. Here we are getting both are maximum and both will give the optimum solution. If it is Z minimum, which I have taken in the previous one, there are two answers, three answers. Minimum is this, you have to conclude optimum value lies at 0, 1. Like that we need to conclude. Students, so like this we will consider all the different types of questions. Now let us look at the last one, last variety in this. Let us consider, carefully observe this. The first one what you worked out. First one what you worked out is both are less than and x plus y, z max equals x plus y. What if there is a condition x less than or equal to 2? So, I am taking into 3 constraints. Students, please note x less than or equal to 2. So, when you, how do you do it? Here 2 point, here 2 point. For this x equals to you write, x equals to only 1 point. Whenever you do not have y, then you have to take a line which is parallel to y axis. So, x less than or equal to 2, draw this line, this is line 3. Now, first line less than or greater than less than, I have to take this region, this and this. Line 2 less than, I have to take towards origin, then I will take this is line 2. Line 3, is it less than or greater than? Less than, then I should take towards origin, which is I will take x here. Students, the dotted lines ticked and the x all are coming under this particular region. Therefore, the feasible region is A, E, this point and this point. This point 1, 2, 3, 4, 5 points. These two how do you get? To find this point, solve equation 3 and equation 2. 3 and 2 you solve, you will get. How do you get this? You have to solve 1 and 3 you will get. Once you get the point, but whether we need this point, no, we don't want. We want only this. So, your feasible region comes like this. If y is less than or equal to 1, then y you have to draw like this, y you draw for 1 and less than. So, you can work out less than, greater than if there is only one variable. Let us look at, if it is understood, this will summarize quickly in the next one.